Hello, I'm Nurul. I'm going to present my paper, User Preference Modeling from Movie Database. I'm from Bina Nusantara University, Jakarta, Indonesia. So this is the outline that I'm going to talk today. I will start with the background, related work, research method, and then result and analysis. And then finally, I will conclude and mention some future work. Okay, let's now start with background. The growth of movie and film industries have evolved massively. When we realize nowadays the quality of the movie that we can enjoy is really good. Yeah, we can enjoy the quality of ultra high definitions 4K image, yeah, like this. While in the past, in 1800, people can enjoy the movie in black and white, and it's very limited. They even don't have any sound at all. Nowadays, people can even enjoy a movie in the palm of their hand. They can browse, they can watch, they can pause, and even they can record whatever they already watch and they like in their smartphone. Most people who are unsure about what to watch usually visit those websites to find some interesting movies. People can visit IMDb, Rotten Tomatoes, Metacritic to find some useful feedback from other users. And then, after we watch the movie that we like, we also can put the rating and review to this kind of website to give the community our thought. For some extent, the movie industry is now interested to dig more deeply into the rating of past movies to make prediction about the movie they should produce in the future. As has been explained previously, the rating is important for people interested in this field. But the problem is that a movie itself can have a lot of features in it, such as director, actor, graphics quality, stories, durations, etc., which can make the ratings meaning become more complicated. In this study, we aim to address this problem by using some machine learning regression algorithm to predict movie ratings. We found some related work that is quite similar with our work. Learning in the movie domain itself has been around for more than 20 years. It started from Group Lens, social computing research at the University of Minnesota, introduced the recommendation system for moviefinder.com in 1996. Then after that, they built a new movie recommendation site called Movie Lens in 1997. Since then, the recommender system research in movie domain became very popular. Many movie datasets have been made available for public. Some related work we can mention here. Published by Augustine and Patak in 2008, they used multi-layer perceptron neural network prediction from a dataset which contained 1,100 movies from 1995 until 2006, and then they found that the mean absolute error in their prediction was 0.983. And then another work by Ping-Yu Xu et al. In 2014, they also used neural network. They say that the neural network performed better than any other learning algorithm. With the prediction, absolute error is below 0.82. And then another work by Latif and Afzal in 2016 found that the use of simple logistic model has the highest accuracy with 84.34%. Joshi et al. In 2017 found that using fuzzy logic and showed the accuracy of 85%. While Bristi et al. In 2019 found that random forest is the winner with 99.24 accuracy after applying some technique, which is called smoothly synthetic minority oversampling technique. Chaglior et al. In 2019 showed that the use of supervector machine was the best model for predicting movie rating. And then Komaria and Kazakov in 2018 also show that using a logic-based learning model can learn user preference from movie rating. So this is our research method that we use in the experiment. Datasets. Our dataset was scraped from IMDb website as available on Kaggle. The datasets contain metadata of 5,043 movies released between 1916 and 2016. The data has 28 attributes available with 7 categorical, 7 text, and 14 numeric. So this is the table which explaining the dataset column and data type. How about data pre-processing? We perform 3 steps in the data pre-processing. First is data cleaning, second data transformations, and the third is feature selections. In the data cleaning, we remove all the missing values. In the data transformations, we use one-hot encoding to transform all the categorical data into numerical data. Feature selections, we use spearmint rank to find the most important attributes. In the data cleaning step, we performing dropping the missing value found in the datasets. And then after we drop all the missing value, we were left with 3,756 clean data. It's complete data record for further process. For data transformations, we use one-hot encoding to convert the categorical data column into numerical type. This technique was chosen to avoid mistreat ordinal value by linear regression model. So in our table, in the table 2, we show the example of original data with categorical column. So we sample some record number, and this record has the content rating label as approved. And then the record number 3,552 has the content rating label G. And then what we do with the one-hot encoding is transform every single class we found in the content rating label as the new column, like this. So the record number 3551, we put the binary value in the approved column, become 1, and the rest become 0, because this has the approved as the content rating label. Okay, and we also apply this for the other categorical column. Next, we perform feature selections. Because of the nature of our datasets with non-linearity correlation, we use Spearman's rank, which is a non-parametric test. And then the following formula used for calculating the Spearman's rank correlations. A high correlation between variables can be very meaningful, which can show that a particular variable can predict the other. We measured all the feature variables correlation with the target output, IMDb score, and select the best. Okay, so this is our learning algorithms that use in our experiment. First is linear regressions, and then the second decision tree regressor, and then the third random forest regressors, and then the fourth is k-nearest neighbor. And this is our evaluation technique. We use the k-cross validations, which divides the dataset into several k, and then test them iteratively by learning aside a different chunk as testing data every time. We use different k between 3 and 10. The loss function that we use in this study is mean squared error. This is the result of our Spearman's rank. So we sort the ranking from the spearman's rank from the highest absolute to the lowest, and then we take only 12 that is relevant to the IMDb rating score. And this is the result of our cross-validation evaluations. It seems that KNN regressor is the worst with the highest mean squared error, more than 1. And then it followed by the decision tree regressor. And then in the third worst place is linear regression. And then we found that the best one is the green one, which is random forest regressor. This is our conclusions. We presented the movie rating prediction based on 12 important features and eliminated some irrelevant features that may affect the model's performance. These attributes were chosen after we conducted the Spearman's rank test to evaluate the correlations of each attribute to the IMDb rating score. We also performed regression tasks to predict the rating score by using 4 regression algorithms. We found that random forest with the number of estimator was set to 20 worked best in our case. With a very low error value, we found that MSE less than 0.8. In the future work, we plan to expand our work for different movie ratings datasets such as the ones from Rotten Tomatoes, Metacritic, and Movie Lens. We can also analyze the reviews given by the user to support the hypothesis. We also plan to use other approaches such as logical-based machine learning, which is a white box approach to learn the user preference. And this is our reference. Thank you.